All right, chapter 19 is going to be about lipids or fats, one of the biomolecules in our bodies. Lipids are basically biomolecules that are soluble in organic solvents and insoluble in water, which is fat. Fat we know is completely insoluble in um, uh, hydrophilic solvents like water, and is insoluble in organic solvents, which are hydrophobic. Um, they are not, they are defined by a physical property, not necessarily by a presence of a functional group. For example, there isn't a functional group for a lipid. There are a few type of groups that are very common about lipids, but pretty much it's a physical property in meaning, just like we talked about in our first line here, in that it is more about that it's soluble in organic solvents and insoluble in water. They contain a lot of carbon-carbon and carbon-hydrogen bonds with few polar bonds. All right, there are three types that we're going to talk about. One are waxes. All right, one of them is what's called triacylglycerols, also known as triglycerides. We talk about them as triglycerides, but they call them triacylglycerols. And then finally, the last one is phospholipids, which are ones that we see in our cell membranes. And this is what are considered hydrolyzable lipids, because we'll also talk about non-hydrolyzable lipids, like cholesterol is a different type of fat, which is not a triglyceride. These all three are very similar to the structure of what a triglyceride is. That's kind of the most common one. But what hydrolyzable means is that you can break it. Usually what it means is that you have some sort of an ester group. So this is an ester, and all three of them have it. And basically what you can do is break this bond, hydrolyze that bond, and break these two pieces in half. And we will see that quite a bit. And the second type, like we talked about, is a non-hydrolyzable lipids, and we will talk about some of those too. The most common one that we'll talk about are steroids. So first, let's talk about the hydrolyzable ones. First of all, we'll talk about triglycerides, but we first have to talk about what's called a fatty acid, because fatty acids are in all three of these hydrolyzable lipids. All right, and what basically a fatty acid is it's a carboxylic acid functional group with several carbons and hydrogens, somewhere usually between 8 to like 21. All right, I believe your book says 12 to 20, but in reality, you can get a lot of them starting from 8 carbons. I believe coconut oil has about 8 to 9 carbons in it. And you could go up to 20 to 21 carbons. So basically, yes, you have an OH group for hydrogen bonding, but remember we talked about you need to have 4 carbons for every OH. Well, in this case, we've got 16 carbons. So this is extremely nonpolar, okay? And this is what's called a fatty acid. It's fatty because you have a very hydrophobic like tail to it, and you have a carboxylic acid group to it. Okay, naturally occurring fatty acids usually have an even number of carbons. Saturated do not have a double bond. We've talked about this. Unsaturated has at least a double bond. Usually it's in the cis conformation. Cis conformation fatty acids are much easier for our bodies to break down. Trans fatty acids you heard of are very bad for us. So are saturated fatty acids. Okay. As the number of double bonds in a fatty acid increase, the melting point decreases. So more double bonds, it's more like an oil, vegetable oils, and more single bonds, you have more saturated fat, such as fat in meats. All right, stearic acid is one of the most common ones. It's a saturated fatty acid. It's got 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13, 14, 15, 16, 17, 18 carbons. C18. It's one of the most common of all of the saturated fatty acids. Oleic acid is one of the most common in unsaturated fatty acids. I believe it also has 2, 4, 6, 8, 10, 12, 14, 16, 18, has 18 as well. So it's equivalent to stearic acid, except you have a double bond. All right, and also we'll talk about this, but that double bond is at 1, 2, 3, 4, 5, 6, 7, 8, 9. At the 9th carbon, so this is what's called an omega-9 fatty acid. You start counting from the tail. All right, so just to kind of give you a heads up, we will see that. Also, I think they're trying to highlight the melting points of these. Notice the saturated has a much higher melting point, almost 4 times, 3.5 times, probably about 3.5 times. Um, no, that's about 4 times higher than if you just have a double bond, because these are able to stack on top of each other. Imagine I have another one here and another one here that they can stack. This can't stack. This is kind of like a ball, and you can't really stack them on top of each other, so it's less dense, therefore it's a liquid at room temperature. Here are some of the common fatty acids from your 12 to 20. Here you can see stearic acid and oleic acid, linoleic, linolenic, um, lauric acid. These are very common. Palmitic acid. You'll see these names quite a bit in foods. All right. Linolenic acid is what's called an omega-3 fatty acid because of the position of where our double bonds are. All right. Linoleic is what's called omega-6. Linolenic is a 3 because you can see 1, 2, 3. That's our first double bond. This is technically called a 3,6,9 fatty acid. This is called an omega-6,9 because 6, 7, 8, and then the 9th carbon. All right, this kind of went out of order, but that's where you get the omega-3s and 6s from. All right, a lot of fish have these kinds of fats in them. Very good for you. Waxes is the first type of hydrolyzable fatty acid that we'll talk about, or fat that we'll talk about, or lipid, I guess technically. And it's basically, so you have your fatty acid, but then you have an ester group. You have another long chain alcohol there. So this is what's called a Fischer esterification. We talked about this in the ester lab. I'm sorry, in the ester chapter. And basically you have a fatty acid attached to an alcohol where your R group is also a very long chain. They'll show you an example here. So this is a 16 carbon chain, and this is for another 16 carbon chain. So you got 32 carbons all within this molecule, and that's basically what a wax is. Waxes are usually 25 or more carbons long. In particular, this wax comes from the fat of a sperm whale. All right. So because the nonpolar carbon chains, because of their long nonpolar carbon chains, waxes are hydrophobic. They form protective barriers on bird feathers, on sheep's wool, on beeswax. So here's just an example of beeswax where you have 30 carbons here and another 16 carbons there. So 46 carbons in total. Very, very nonpolar. All right, and again, it's hydrolyzable because you can split this ester bond by hydrolysis. So you have 2 hydrophobic regions in this case. All right, so here we go. Here's where they talk about the hydrolyzability of the compound. But once again, you're breaking the ester bond to form bonds, so you form the fatty acid and alcohol, and you do this in the presence of acid and water. All right, triglycerides. Your book's going to call them triacyl glycols, but we know them as triglycerides. They are 3 esters on the same molecule by a glycerol compound, 3 fatty acids. Okay, so this compound is glycerol. It's 3 carbons with 2 OH groups. I'm sorry, 3 carbons with 3 OH groups. All right, so notice you have alcohol. You basically have what's called a triol. All right, triol meaning 3 alcohols. And then you have 3 different fatty acids, or 3 of the same fatty acids that do a Fischer esterification on them, and you form a triester or a triglyceride, where your R's are like stearic acid, linoleic acid, linolenic acid, oleic acid, whatever your R's are. Okay. So here's an example of a saturated triglyceride. These come from the fat from steaks and hamburgers and things like that. You know, somewhere between 15, 16, 18 to 20 carbons long. All right. You can also have what's called a mixed triglyceride, where you have 2 or 3 different fatty acids. All right. Here's an example of a saturated. Comes from animal fat, room temperature usually. Unsaturated usually have kinks in them. All right, like we said, so they're usually vegetable oils. They are liquids at room temperature. We also have what's called monounsaturated. That means 1 alkene or a double bond. Polyunsaturated means you have more like an omega-3, 6, 9 from fish. Increasing the number of double bonds decreases the melting point. We've already talked about this. Again, they're mostly cis, so there's nothing new here. Fats have relatively high melting points. They are usually solids at room temperature. These are usually saturated fats. Fats are derived from fatty acids with few double bonds. Oils have lower melting points and they are liquids. All right. Oils are derived from fatty acids having a large number of double bonds. Okay. Again, we've talked about this. This is just kind of showing you examples: lard and butter and shortening. Notice more than what do they usually say, like 40 to 50% of your molecule is saturated. I guess 22 is a little bit low, but if you talk about lard and like butter, however, the oils you can see pretty much less than 20% in most cases. Now, palm oil and coconut oil are relatively saturated. You know, it is called coconut oil. I don't know if you've ever used it. It is kind of a white solid. It looks like wax, but it has a very low melting point. It doesn't take a lot of heat for it to actually melt. And it's pretty good for you. It's a much shorter chain of carbons. It's not as long a chain as lard and butter and shortening. Um, um, and then you have here some margarine and spreads, which is kind of a combination of things. All right, here's some health and medicine. We know fats are used for our cell membranes to insulate. Fats very important in our diet. You know, having a low-fat diet is actually not a good idea. Having a low saturated fat diet is a good idea, but not having a low-fat diet. You need to have fat in your diet. You have to have fat in your diet. All right, it does store energy, but if you eat the healthy kind, it doesn't really stay in our bodies. They recommend 20 to 30% of a person's caloric intake from lipids. Um, very low saturated. Try to keep the saturated, except for like coconut oil, which is a special type of saturated fat. Saturated fats also stimulate cholesterol synthesis, which can lead to cholesterol plaques building up inside arteries, high blood pressure, heart attacks, and strokes. All right, here are some examples. Here are some saturated fats. Here's some unsaturated fats that are found in oils and nuts and avocados and things like that, which are very good for you. All right, here's some more examples of saturated fats. They're in the foods that we love to eat: donuts and cupcakes and fried chicken and biscuits. Unsaturated triglycerides or triacylglycols lower the risk of heart disease by lowering cholesterol. Usually the omega-3s are very helpful in lowering the risk of heart attack. If the double bond of unsaturated is trans, though, you lose all of the good effects. All right, trans fats are synthesized when you do these partially hydrogenated compounds. They actually turn cis compounds into trans compounds. All right, so we will stop right there, and we'll come back and start 19.5.